Let's take a look at problem number 37. And there we go. And this is simplifying complex rational expressions. Now, to understand the steps I'm going to put here, let me just refresh your memory. And maybe I have a little bit different definitions than others. This is a complex fraction, not necessarily a complex rational expression, because these are all numbers, though it does fit that definition still. And so we have fractions inside of fractions. That's what the complex part is referring to. This fraction here is an inner fraction. We actually have 4 inner fractions: 1/3, 1/5, 1/7, and negative 1/4. And this particular one here would be an inner denominator. And we have 4 of them. We have 3, 5, 7, and 4. So that's the denominators inside, not the entire one out here, but the ones inside. So keep those in mind. So step 1. Factor all your inner denominators. Step 2, figure out the LCM of all the inner denominators and multiply everything by them. When I say everything, I'm talking about things separated by pluses and minuses and the division symbol itself, the fraction symbol. Step 3. Now, what goes along with this, I'm not writing down, is true wherever we are in math, is combine together like terms, combine together numbers. Factor the top, factor the bottom. And step 4, cancel if possible. Again, I'm writing this as if they were something you could factor, like x squared minus 9 and so forth. Not like this, though those steps would work on this. Well, let's look at that problem. Our first one, number 37. There we go. Then we got 4 over x plus 1 over 3x all over 4 over 3x minus 1 over 2x. Now, go back to my steps. First step, factor all your inner denominators. X, 3x, 3x, and 2x. I can't factor anything there. So we jump directly to step 2, figure out the LCM of all your inner denominators and multiply everything by them. Well, if I look at the numbers, 3, 3, and 2, and I figure the LCM of those separately, that's 6. And for the x, this is a single x, and I'm looking for the greatest number of single x's in any single inner denominator. So there's 1 here, there's 1 here, there's 1 here, and there's 1 here. So the greatest number of single x's in any single inner denominator is 1. So we're going to have 6x. And that's what I multiply everything by. Multiply by the 4 over x, multiply by the 1 over 3x, multiply it by the 4 over 3x, and multiply it by the 1 over 2x. Now when you do that, these x's cancel here, these x's cancel here, x's cancel there, and x's cancel there. Now we can do a little bit of simplifying here. Here we got 3 and we got 6, they're both divisible by 3. 3 divided by 3 is 1, 6 divided by 3 is 2. And here we got 3 and 6 again, they're both divisible by 3. 3 divided by 3 is 1, 6 divided by 3 is 2. And here we got 2 and 6. Those are both divisible by 2. 2 divided by 2 is 1, 6 divided by 2 is 3. So let's see what we have left. 6 times 4 is 24, plus 2 times 1, 2, over 2 times 4 is 8, minus 3 times 1, That gives us 26 over 5. Okay. Factor the top, factor the bottom. Well, these are just numbers. And while that factors the 2 times 13 doesn't really benefit us any, because nothing's going to cancel. So 26/5 is our answer. Looks like C. So, what was that? 37C. Let's check that. And it checks.